Hi class, this is lesson 8.1 on identifying quadratic equations. Okay, so the first thing we need to put down is what a quadratic function is. And so everything we've been graphing so far has all been linear, meaning we're graphing a straight line. Today though, we're going to be graphing quadratic equations, and those look like what you see over here, where we have a U-shaped graph, and that's called a parabola. And the way we write quadratic equations is that every single one of them is going to have an x squared value in it. Okay, and it can be written, here's the standard form right here. So we'll have ax squared plus bx plus c. So it has to have an x squared value, and then you have to have a regular x value and a c value. Now, a has to be a number, but b and c could equal 0. So what they have down here is they're just saying that this would also work, where you have 0x and a 0 for a constant. Okay, so when we're looking at a table of values, when we were doing linear equations, we would look at the first differences between our y's. So like up here, as x increases by 1 each time, our y values they're increasing by 1, 3, 5, 7. But we want to look to see if so that would be the level we're looking at if they were linear. To know if they're quadratic though, we're going to look at this second level of differences. So our difference between 1 and 3 would be 2. 3 to 5 would be up 2, and so on. So since those second differences are all the same, then we could say that this is a quadratic equation. Okay, so let's look at some examples here in order to tell if it's quadratic or not. So first of all, we're going to look at all of our y values, and we're going to see how much they're increasing or decreasing by each time. So on this first one, it went up 7, then it went up 1, then it went up 1 again, and then it went up 7 again. Okay, so that would be our first level of differences. Our second level of differences then, between 7 to 1, it went down 6. Here it went... Okay, and this next one, it went up 0, so that's just a 0, and then here it went down 6 again. So these second differences are not consistent, so we would say that no, this is not a quadratic function. Okay, and then we would do the same process on ones that look like this. So again, you're going to look at all of your y values, what's your difference between each one, and then you want to look at the second level differences. So I'm going to let you do this one on your own, but I want to show you one more time how you can tell on ones like this. Now, if you remember from earlier, it's got to have an x squared value. So since I have no x squared value here, this one would also be a no, not a quadratic. Okay, now this next one though, it does have an x squared value, so then this one would be yes, it is a quadratic equation. Has to have that x squared value. Okay, go ahead and try this one on your own then. Remember, you're going to do it the same way as we did on this example. Okay, the graph of a quadratic function is a curve called a parabola. We've talked about that before, just meaning it has to have a U shape. Okay, and so on all of these, in order to graph them, we are going to pick some x values, enough of them so that we can see the shape of the parabola. Okay, so for example, maybe I'll start with -2, -1, 0, 1, and 2. So then all I'm going to do is, once I've picked my x values, I'm going to just plug those in for x in my equation and then solve for y. So over here I'd have 1/3 times -2 squared. Now remember, when I take -2 squared, I'm taking -2 times -2. So that's going to give me a +4, and then +4 times 1/3 is going to give me a 4/3. Okay, I'm going to do the same thing with my next one then. Plug in x, solve for y. So I'm going to get 1/3 when I do that, and I'll get 0, and then 1/3 and 4/3. Okay, and then once I've got my points, I can go ahead and graph those. So I've got -2 4/3. Remember, that's about 1 1/3. -1 1/3. 0 0 1 1/3, and 2 and 4/3. So I graphed enough that I have my parabola shape, and so that's what I want to go for. If you graph it and you get kind of a weird looking shape, either check your values, check what you plugged in and make sure you got the right y values, or else maybe try some different x values and see if you can just get a different section of the parabola to make it look correct. Okay, so go ahead and try these other two on your own. Remember, you're going to pick your x values, plug in, and solve for your y values, and then you'll graph them. You should get a parabola. Okay, now when you were doing those last ones, you should have noticed that one of your graphs opened up, a parabola going up that looks like a U, and one of them opened downwards. And here's how you can always tell. If your a value, so that's what's in front of your x squared, is bigger than 0, then it's going to open up, and if it's less than 0, it's going to open down. Okay, so on all of these, we're going to need to first of all put them into standard form. So remember that our standard form looks like this: ax squared plus bx plus c. So we have to get y alone. Just like when we were doing linear equations, we have to get y alone first. So on this one, I'm going to add 1/3 x squared to both sides. So that way, that negative 1/3 x squared will go away from this side, and I'll be left with just y over here. And then I'll rewrite my equation in standard form then. So I'll have 1/3 x squared plus x minus 3. Now I can look at my a value. Remember, my a value is whatever's in front of the x squared. In this case, it's 1/3. Since it's bigger than 0, then I know that my parabola is going to open up. Okay, let's do one more like that. Okay, this one's kind of nice. Y is already by itself, so I don't have to do any of the solving that I did on the last problem. I just need to identify my a value, which in this case would be -3. It's whatever's in front of your x squared. So in this case, my parabola is going to open down. Okay, so it's going to look like this kind of shape. Okay, whereas this one opens up, so it looks like this. Okay, go ahead and do these next two on your own. Okay, the last couple things then here. The highest or lowest point on a parabola is something called the vertex. Okay, if the parabola opens upward, the vertex ends up being the lowest point. And the opposite would be true if the parabola opens down then. So on these examples, here would be the minimum, the vertex, and here would be the vertex, which is the maximum value. Okay, so on all of these, we're just looking for where the parabola changes directions. So on this one, it looks like our vertex would be -3, 2, would be the point of our vertex. And then this would be the minimum value, because you can see that the parabola goes up from that vertex. So that would be the minimum, and then everything else on the parabola is going up from there. Okay, on this next one, it looks like my vertex would be 2, 5. Okay, this point right here, and then this, in this case, this would be the maximum because my parabola goes down from there. Everything else is located down from that point. Okay, go ahead and do these next two on your own. Okay, and then the last part then is finding the domain and range when you're given a graph. Okay, so remember that domain is all of our x values and range is all of our y values that the function covers. So it says here, unless a specific domain is given, you can assume that the domain of a quadratic equation is all real numbers. So I want you to underline that so you remember it. All real numbers for your domain. That just means you can pick any x value, and at some point the parabola will hit there. Okay, so the range then, if we look at this example here, the range is all of our y values that the parabola hits. So in this case, the parabola hits all the y values that are greater than 1 right here. So anything up from 1, the parabola would have a y value for. So we're going from that minimum value, and it's going up in the direction of our arrows. So we would say that our y value, our range, is y is greater than or equal to 1. Okay, on these ones then, we're going to start with our domain. Our domain is always going to be all real numbers unless it says otherwise. And then our range is our y value. So we've got to look Our vertex is right here, and then the parabola goes down from there. So our range value is going to be y is less than or equal to our y value right here, which is -3. Okay, so anything less than or equal to -3 on that y-axis, our parabola will hit those y values. Okay. On the next one, here's our vertex. So, well, first of all, we can do our domain. Our domain is always all real numbers unless stated otherwise. And then for our range, this time the parabola is going up from that vertex. So my range is going to be y is greater than or equal to my minimum value here, which is -4. So anything up above -4, that parabola will touch at some point. Okay, go ahead and try these next two. And then that is it for our lesson. So try those next two. Make sure you check all of your answers on my answer key, also located on my website. Okay, good luck.